All right, this is the second set of note sheets called Congruent Triangles Day 2. It has a hanger, like a clothes hanger at the top of it. So we're continuing on how do we tell if two triangles are congruent? What are all the things we know? We've only learned side, 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 and side angle side, so we're going to continue on learning some more. All right, so in this first little section up here, they ask us, are the following triangles congruent and why? Well, remember when we look at a figure, we should always mark some things if we see them, like vertical angles, or in this case, there's a shared side. And so I'm going to put one mark on it since they put two marks on the other sides that match up. Now if you look, I have a side, an angle, that's an included angle, and a side in the top triangle. And I have a side included angle and side in the bottom triangle. So these are congruent by side angle side. They match up, and we've had that theorem. And if we look down here, the other theorem we had on the first set of notes was side, side, side. Again, as we first look at this figure, we notice there's a shared side here. I'm going to put one mark on it. Okay, so that side matches with that side. These two sides match up, and these two sides match up and are congruent. So this one would be congruent by side, side, side. Okay, so now there are some other theorems, and here's what we're going to get into them. Okay, now we're going to talk about an included side here. Okay, so in this blank you're going to write included side. Included side. Trying to write the best I can, but you may have to listen to tell what something's supposed to be if you can't read it. All right, side between M and S. Okay, so here's our angle M and S. What side is included there? It would be side MS. This one right here, wouldn't it? So that's what it means to be an included side. I can list the distance, or I can put the line segment over it. I don't really care which you do. Okay, now what is between M and L? Well, the side that's included between those two angles is this side right here, which is LM or ML. It doesn't matter what order you write it in. You can put a line over it, or you can leave it just like that. Okay. And so on our last one, what side is included between L and S? And that would be the side LS or SL. I'll just write LS, and I'll put a line over this one just so that I'm, kind of being consistent. Okay, so now we're going on to the bottom of the page. Here's another postulate that proves triangles are congruent. It is angle, side angle, so we write angle, S for side, A for angle. That's how you abbreviate it. Nobody ever writes the whole thing out. If two angles in the included side of one triangle are congruent to corresponding two angles in the included side of a second triangle, then the two triangles are congruent. So for instance, let's say there's all kinds of ways that could happen, but let's just say I had this angle A and this angle B, and then this angle R would be congruent to A, and this angle S would be congruent to angle B. And then I knew that this side, which I'm going to put one little mark on, side AB is congruent to side RS. So let me write that for you. Okay, I could have picked any, two angles in their included side, but I'm just giving you an example here. So if angle A and R are congruent, B and S are congruent, and the line segment AB, which is between the angles A and B, and the line segment RS, which is between the angles R and S, they are included sides. Then those triangles would be congruent, so I could write triangle ABC is congruent. Oops, there's the congruent sign. So this is going down in this blank right here, okay? Is congruent to triangle RST. Remember, we have to match everything up, and exactly A's got to match what it's congruent with, and it's congruent with R. Since B is congruent with S, they're going to both go second, and that leaves C and T. Now, are the two triangles down here congruent? When we look at the figure, we notice there's a shared side, so I'm going to mark it right there. So I have this angle and this angle congruent to each other. I'm going to use some colors here to help me out. I have this angle and this angle congruent to each other, and then they have this shared side that I'm going to mark over with a green tick mark. So those are congruent by ASA, and if I wanted to write the proof with that, I would just need to, they would probably have put some letters on here, and we would just say these two blue angles are congruent, those two red angles are congruent, and that side's congruent to itself by the reflexive property, and so the two triangles are congruent by angle, side, angle. Okay, moving on to the next page, we have another reason to prove congruence of two triangles, which is angle, angle, side, two angles in a row, and then the side that immediately follows that last angle, okay? You could read it backwards and say side, angle, angle, so you kind of go to your information, you find like a good place to start on it, and then you kind of go to the consecutive things that are marked, and that's how you find your angle, angle, side. For instance, if I had angle A is congruent to angle R, angle B is congruent to angle S, and then we marked the very next side after angles B and S congruent with one mark, that would be angle, angle, side. Notice the two angles are in a row and then immediately that side comes, okay? That's how you know it's angle, angle, side. If you had for some reason decided, I'm going to see what's in this triangle, and I started like over here with the line, that would be side, angle, angle. Well, what you do is you just read it backwards. Oh, that's really angle, angle, side. Okay, so you always write angle, angle, side, but you can read it starting at A going around to C, or starting at that line CB going around to A. You just kind of always look at it in reverse if it's something you don't recognize. So in this case, these triangles would be congruent, so I could write angle triangle ABC is congruent to triangle RST. Okay, so there's another. I think that's our third one so far, maybe, or maybe it's our fourth. Okay, so are these two triangles congruent? Explain. Okay, so first of all, remember, we got to mark anything on the diagram that we see is congruent that they didn't mark. They marked a set of angles congruent and a set of sides, but that was it. So that's only two pieces of information, so I'm kind of looking to see is there something going on here, and there is. Right here, I'll mark it with two marks. There's vertical angles, so these two vertical angles would be congruent. So let me use a green marker to show you how I'm kind of looking at this. Let's say I started right here and notice there's a side, and there's an angle, and there's an angle. Oh, that's angle, angle, side, isn't it? Okay, well, let me go check and see if I have the same thing over on the other side. I'm going to start with that one line. There's the side. And then the angle with one mark. Oh, there it is over here. There's my angle there. And then I've got these two angles across from each other. That's the other angle. So that's angle, angle, side, or side, angle, angle. We would say these are congruent by angle, angle, side. So again, if we were to put this in a formal proof, we would just list the angles that were congruent to each other, list the sides that were congruent to each other, list that those two angles that are vertical angles are congruent because they're vertical angles, and then just say the two triangles are congruent, and our reason we would list would be angle, angle, side. These are the simplest proofs because all you're just doing is listing the three pieces of information that are congruent and then finding the little theorem that goes with them. Now, we have one for right triangles is our next little thing we've got going on down here. Here's another theorem, and really it's the same thing as something else. It's just nice and handy because we don't have to do so much work. If you have a right triangle, you always know there's two congruent right angles, and so they mark the right angles. We're going to look at those as being marked congruent because we know all right angles are congruent. So they're all 90 degrees, right? Well, this theorem says if you got a right triangle, which we do, and you notice that you've got the hypotenuse congruent in both triangles, and then a leg, then you have congruent triangles. So you got the hypotenuse and the leg. That's called the HL theorem. Now, this does not work in just regular old triangles. It only works in right triangles. If you look at this, there's one theorem we never have in geometry. And it's kind of easy to remember because if you say it a certain way, it's considered a not polite word to say out loud, and your moms might not be happy to hear you going around saying, I studied the blank theorem today. And that theorem, I'm going to write it backwards, SSA. If you read that backwards, that's a word you wouldn't want to say out loud much, and your mom probably wouldn't appreciate you going around mouthing that off very much at home. So that is a theorem that never works. If it's SSA or if you read it backwards ASS, not a theorem in geometry. The only time it does work is when we have these right triangles. So if you look at this, here's the right angle, right? And then you have a side, and immediately you have another side. Well, just to kind of differentiate, because we don't want to say this is a theorem, since it only works in right triangles, we decided to call it the HL theorem instead of the SSA only in right triangles theorem, okay? So if you have the hypotenuse and the leg congruent and two right triangles, the two triangles are congruent, so we could say triangle ACD in this case. If I go in that order, I need to list in order over here. I would need to go from D to, gosh, I can't even read that anymore, F. That's an F there, DFE. I had to look back at my paper that I took a picture of to make the video on. Okay, so that's the HL theorem. So here's two more new ones. I didn't circle them on the first page, but you can kind of figure that out, I think.